Yep. Hello, everyone, and thank you for attending this webinar from our side as well. My name is Dimos Tsagrasoulis. My job position is project manager at the Vattenvolt company, and we are leading the activities for the development of the self-correcting intelligent building energy management system within the Heat4Cool project. I would like to apologize to all of you due to some technical difficulties. I am not able to navigate the presentation myself, so I'm kindly asking Serena to to navigate through it. So, without further ado, what is the SCI-BEMS system? It has two main functionalities, and it's applicable in two main areas within a building. On the one side, we have the monitoring and control of the centralized heating and cooling generation system, which is the main, let's say, technological aspect of the Heat4Cool project in general. And on the other hand, we are also interested in within the apartments to apply automated control in order to satisfy in the best optimal way the end user demand. So, Serena, if you can please move to the next slide. Uh, as I stated, two main objectives, let's say, delineate the functionality of the SCI-BEMS system. And these are, on one hand, to enable real-time monitoring of the complete system, and of course its individual components, with the goal of establishing, let's say, the details about its performance, its operational status, and the subsequent functionality that runs in parallel is to allow through the BEMS system to apply optimal automated control strategies, both actually within the premises as well as via remote communication. Uh, Next slide, please. So, I will briefly discuss the main topics of the SCI-BEMS system, and the next one in this presentation is the control principles. So, how did we define which is the best way to operate the system? Uh, for this, it is important to distinguish between, as I said, the centralized, the energy production and supply system, as well from the one side, and on the other side, the demand of the occupants. For the optimal use of the heating and cooling production systems, the optimal control principles were defined uh, with the work of the responsible partners as well as the pilot sites were defined after rigorous simulations followed by testing and taking into consideration the different environmental conditions and setups of the pilot sites. So the central system always operate under certain rules that guarantee on one hand the safety of the equipment and the optimality of the use of the system. Now on the demand side, we are exploring the automated application of control logic that that guarantees the comfort of the users but also the, let's say, minimizes as well as possible the demand that is needed in order to provide energy efficiency. I will come back to this automated control a bit later as well. Next slide, please. This is just a visual illustration of what I was talking about, the automated control. So through the laboratory monitoring equipment installed, we are able to pass to the cloud services the required signals in order to perform the optimization of set points for the different apartments, and these control signals are then communicated back to the individual apartments for applying them for applying the control to the different thermostats. Uh, Next one, please, Serena. So now, what about infrastructure? I'm not going into detail about the centralized systems because, as I write in my presentation, each pilot site is more or less unique, and to the needs and requirements, the solution is very much tailored to the particular buildings. Furthermore, you will see this information in subsequent presentations from the pilot managers. What I would like just to stress that all pilot sites have in common is the multitude of metering and monitoring devices that are installed there, which allow the real-time monitoring and subsequent evaluation of the system. Within apartments, the one common solution was adopted, which is versatile enough to be installed in different premises. Serena, can you please go to the next slide so that so the solution is based on various sensors which wirelessly communicate to a gateway, and this in turn then passes the signals to the through Wi-Fi um, to the World Wide Web, and allow us to get this and process them, as I mentioned earlier, in our cloud infrastructure. So this system, in tandem to the control logic, uh, uh, creates the basis for the functional operations that I'm going to discuss briefly now as well. So, what is the functional pipeline for the automation? The main objective, as in any energy management system, is to perform energy efficiency, and in our particular case, our main objective is to, let's say, cleverly handle and manipulate the required demand of the apartments for heating and cooling. So, in order to do so, uh, we learn via the past measurements that we have on HVAC actuation from the occupants, and then coupling that to the environmental conditions, we learn their comfort preferences. And since it's a machine learning approach, can guarantee us a consistent and automated manner to do so. These constraints are then comprise an input to a model predictive optimization of the system's set points. And these set points are continuously transmitted to the system for operation, of course, under the requirement that users always have manual control in order to bypass this, from which events we are also learning in order to adjust our, let's say, comfort preferences. So the last slide, please, Serena, is just a visual illustration of the process that I just now reported. So going from monitoring and communication to comfort profiling, and then to optimization, which leads to the automated control. So as a summary, the SCI-BEMS system in the Heat4Cool project tries to, let's say, provide on the one hand all the monitoring infrastructure and the numbers, the values that we need to evaluate the performance of the systems, and on the other side to provide, let's say, an occupant-centric control approach. So thank you very much for your time, and have a good remaining of the webinar.